So the web is as hot as ever, unsurprisingly, and web components seems very interesting. So let's give a warm applause for these two guys.
Thank you. Okay, let's start with our talk about web components. Maybe first some words about us two. With me here is Michael Heinrich. We are both from, and I, Hendrik Ebbers. We're both from Canoe. It's a company from Switzerland that does some UI-related stuff, or a lot of UI-related stuff. And we want to talk about web components today. So the content of our talk is, first we want to show the web component specification. Then we want to show something that is created today. It's called web component polyfills. By using them, you can use a lot of features of this specification today. Then we want to show Polymer, which is the web component implementation of Google. And at the end, we want to talk a little bit about perspective, what maybe will happen in the future with this new technology. So before we start, I think, so normally we both come from the Java side and not from the HTML or website. And in HTML, there were a lot of so-called revolutions the last year, a lot more, for example, than in Java maybe. Like, so it all started with HTML, but then we had JavaScript and HTML5 creating web applications. Then with the iPhone and Android, mobile was an important topic with responsive design and all this stuff. And later today we use AngularJS to create web applications. So there are a lot of new technologies and a lot of new steps in web development. And we think what we want to show today for web components is the next step in this line. So maybe it's the next revolution of the web or the next revolution of web development. So before we want to start, we have two slides that will introduce Bauer, because maybe some of you haven't done web development with HTML and JavaScript before and normally do Java stuff, and maybe they don't know Bauer. So Bauer is a package manager for building web applications. It's like something like Maven from the Java world for the web. So, and we will use it in our talk, and therefore we want to introduce it. It's created by Twitter and it's open source, and by using Bauer, you can define dependencies of your application, of your application, and then Bauer will automatically install these dependencies for you in your project. So there are 3 simple commands to install Bauer. You just type the first line, but you know Node.js and Git and all the stuff to install it. But once it's installed, you can, like using Git, go into your project folder and just call Bauer init. And by doing so, it creates the Bauer file. It's a JSON file that is the Bauer description. And then you can simply install new dependencies. So in the last line, we install the web components JS package or module. This is a dependency. And by doing so, this will add it as a dependency to the Bauer file that describes the application and directly download the module and add it to the dependencies of the projects. So this just to start. And now Michael will tell you about the web component specification.
So, hello everybody from my side as well. When we do web development, we have a problem nowadays. When we look at the typical website, so here I have the YouTube website, we can see a typical website nowadays is made up of components, so little pieces, and you assemble your web application from these components. It's not like in the old days when you actually had something like a document where HTML was working fine, but now you work with components. When we look at this, we have a menu bar, we have a navigation bar with buttons that consists of an icon and some text, and then we have those little teaser cards where you see the thumbnail of a video plus a short description. And when you actually looked at most websites nowadays, or most web applications, all of them are made up of these components. But when we look at the code, there's a huge gap. So this is part of the YouTube website. So we can see we have divs like nested into each other. We use classes and IDs to kind of get a hold of this div, and then we code our implementation or our functionality based on these classes and divs. And it's really not very intuitive, and it's not really easy to look at that and be able to maintain it or actually even write it. When you think about it, this code, all it does is actually this. It's just showing a thumbnail plus some text. And actually, it's not even, that wasn't the whole code. But this is the code that we use nowadays to show an image plus some text. Like other people can write games with that many characters. We just use it for such a small grid item. But wouldn't it be nice if our applications, the code to write our applications, would look something like this? There's a shelf, which is the outermost tag, a container. It has a title plus a number of subscribers. And then we have a grid item, which also has a title, a URL, a thumbnail. And it's, you just look at it and you know immediately what's happening and what this thing is doing. And web components will give us this possibility. Web components consist of 4 parts. So there's the element template, the shadow DOM, the custom elements, and the HTML imports. And these 4 parts together make what's called a web component. And we go through each of these parts now step by step. So let's start with the element template. In this example, I wrote an activity stream. So I guess most people are familiar with this. You have it on websites like GitHub, but it makes sense for a lot of web application and scenarios where you just want to have some overview what other users were doing. So it's a very typical requirement that you have for web application. And when we look at the code to write this kind of activity stream, we can see we have this outermost container, the activity stream, we have a title, and then we have lots of divs. On each of this div makes one of these activity cards, which has the thumbnail, some content, and the timestamp. And when you look at it, you can see that there's lots of boilerplate code, which is just copied over and over again. We have to specify it for each single card. And wouldn't it be nice if we can just specify this boilerplate code once and reuse it and inject it every time where we need it. And the template element allows us to do just that. So how does it work? When we look at the example, we'll just look at this one activity card now in this talk. And how can we make a custom web component from that? So this is our code like it is today. The first thing we need to do if we want to reuse it and use the template is the template element. We specify the tag, the template tag, and we give it an ID because later we need to access that with JavaScript and use it. And then we just copy all the boilerplate code into this template element. Now, if you look very closely, you will see that the source of the icon isn't specified yet. Well, if you do that on a website, you get an error because source is a required attribute for an image, and it wouldn't work. For templates, it's different because everything that's between these template tags is ignored, first of all. The browser, if you reference some source, some resources, they are not loaded yet. If there's some JavaScript inside these template tags, it's not executed at this point. It's completely ignored. So we copy all the boilerplate code in there, and then we can remove it from our main website. And to use this template now, we need to use JavaScript. So first we need to get a handle to the template. So we can just use the query selector. It works very much like a jQuery. And I think most people are familiar with the with the way how you access the DOM using jQuery. The query selector, it's a pretty new function that gives us that, and it's part of the standard. So we can use that to get a handle to the template. And then we call the import note method and pass the template content. That's slightly surprising. The template content points into all the children of that template element. And by doing this and passing the true argument, we do a deep copy of everything that's within the template. So we take all the parts, the div, the image, and the other divs. We copy all of that, and we have then the root node and clone points to that. And last but not least, we can just add this element into the DOM. Before we need to do that, we need to specify the missing pieces. So for example, we have to change the source for the image. But once that is done, we can just add it and use it as with usual DOM elements. What's maybe a little surprising first time you work with a template is that it doesn't allow you to do something like this. This is from AngularJS. And it allows you to specify some properties, some data, and does a binding and updates the website automatically once every time the data model changes. But that's not supported. Exactly. So that doesn't work. It's surprising. It doesn't work. This is called data binding, and it's not the same as templates or what templates are supposed to do. Right? You just have to keep it in mind. There are libraries which allow you to do data binding, but the standard doesn't support it. The standard is just for the static parts of your website. The browser support is actually quite good for the template element. It's supported by all major browsers in recent versions, except in Internet Explorer. Well, kind of expected, right? So, but there is this polyfill library that you can use, and with that you can use the template element even in the Internet Explorer and in older browsers. Okay, so we looked at the template element. Next puzzle of the piece of the puzzle that we need to look at is the shadow DOM. When we do a web component right now, we have a problem. So let's assume this is our website, the blue part is our website, and the green nodes, that's our web component. And now, by accident, because we have different developers working on the web component and the application, we use the same class twice in the web component and in the DOM. What happens if we try to query this node or all nodes from this class? Well, what happens is we get both, right? And the same also applies if we use CSS. We would get both nodes. And so by that, we could accidentally change and interfere with the web component, even though we don't really want that. We just want to access our own node, the blue one on the left, right? We don't want to actually change the web component. So what we actually need is we need to kind of be protected from accessing these web component nodes so we don't interfere with them by accident. And the shadow DOM allows us to do just that. So how does it work? If we have our application, our DOM, the shadow DOM kind of removes the web component from the DOM, and it's not visible anymore for us. So we would just add the we just can access the blue nodes. The node on the left, that's part of our DOM, that's called the host. It has a reference to the shadow DOM, to the root node of the shadow DOM. So there's a connection between these two. But when we work on the DOM, we just see our blue nodes. Just see our blue nodes. But when the browser renders the DOM, or the website, it actually takes the shadow DOM and renders that as well below our host node. So going back to the problem we had initially, so the shadow DOM is not visible to us. So if we have the same scenario, we have the node here with the content class and we have our node up there with the content class. Now, if we try to access all nodes with the content class, we would just get our node, because this part is not visible to us. That's the shadow DOM. Okay, so how can we use that? Let's say this is our given scenario. We have the host node where we want to attach the shadow DOM to. So we need to call a method, create shadow root, on that node, which gives us a handle to the root node of the shadow DOM. Right, that's what it creates. And then we can just append children and create the whole shadow DOM, because as long as we if we have a handle to the root node of the shadow DOM, we can append children. Just when we try to search over the whole DOM, we don't see the shadow DOM anymore. Now, certainly this is kind of cumbersome, right? We don't want to really assemble our application and attach nodes in JavaScript. And now we can see how all the different parts of the web component standard fit together. Because what fits nicely here is now the template functionality. Again, we start with the host node. We create the shadow root. And now we can take the template and create our clone, like we saw in the example before. And then we can attach this clone to this creates the subtree, and then we can attach this root node, or this clone, the copy from the template, to our root node. And by that, we can now specify what we want in the shadow DOM in HTML. So we can just put it into between the template tags and specify it that way, declarative, and we don't need to specify. We don't need to do everything in JavaScript. So, and that attaches the root node to the clone. Browser support is not so good anymore. It works in Chrome and Opera, but it's not supported in the other major browsers. But still, using the polyfill library that Hendrik will talk about in a little while, we can actually use this functionality today for all major browsers. So, now we looked at the shadow DOM. Next part, we need to look at our custom elements. So, when we look at the website, how it is right now, we have this div, which has the class activity, and we have the content inside. One issue is, how do we actually store things like the timestamp or the source of the icon that we want to show? So how can we use that can we do that in a meaningful way? And when you think about it, you will start to wonder, what's a div with the class activity anyway? It doesn't give you any methods or any properties that would make sense at this point. It's just a very general container, and you have to add everything manually. That's almost like using a Java object for everything and then adding your functionality manually. So we don't really want to use that, but what we want is to do something like this. Right? We want to specify, we want to have a meaningful tag which shows us exactly what we want to do, plus some attributes that have meaning, so that we can specify the icon source, we can specify the timestamp, and we can just look at it, and even though you may have never worked on this application before, you know exactly what's happening, what the thing is doing. And custom elements provide us this functionality. So how can we use them? To create a new custom element, we need to extend HTML element, or in JavaScript we have to create a new prototype which is derived from the HTML element prototype. I assume there are some people here who are not that familiar with JavaScript, so I tried to translate this functionality into the Java world, what this kind of matches if we would do that in Java. So what we do here is we extend the class HTML element with a new class activity card. And then we need to have a handle to that class. So in Java, we would then be able to create instances from that with this handle activity card class. And in JavaScript, it's very much the same. We have this activity card prototype, which is derived from the HTML element prototype, and we can then create new instances using this prototype. The advantage in JavaScript is that we can actually change the prototype now, and we can add new methods, we can add new properties to that prototype during runtime, and we don't have to specify all of that up front like we have to do in Java. Next thing we need to do is we need to create some options. It's a new class which has the property prototype, and we need to pass in our new prototype that we just created. If we try to translate that to Java, it's like we need to create a new options class, and then we pass in this handle to the class so that the options know what class the new element needs to be derived from. And then we call the document register element method. We pass in the name of the new element that we want to use, plus the options that we just created. That would actually look very much similar if we would do that in Java and had this API. How can we use that now? So, and with this, the element is now known to the browser, and it can use it, and it provides all the functionality that we pass to the prototype. So if we add a new method, some new properties, the new element will have these properties and methods now. How can we use that? Well, we really just get what we wanted. We have this new element, activity card. We can add our own attributes the way we want it, have some content inside, and give all the new functionality that we wanted. Very important at this point is to note that we need to use a dash in the name. That's one of the requirements for custom elements, because there may be that way it's ensured that you don't interfere with maybe new text that will be added to the HTML standard, something like this. So you need to have a dash in your name. Very important to know about these elements is there are 4 events that can happen. There's a life cycle. Create, this event is fired when a new element is being created of that type. We have the created callback for that. Attach is another event that's fired when you attach the node, or when the node is attached to the DOM at some point. Then this attach event is fired, and detached, this callback is fired if the node is removed from the DOM again. And then there's this one special event, change. That's called every time an attribute of this new element changes. And there you have some parameters. You get the attribute name, the old and the new value. And with that, you can implement pretty much all of the functionality that you need. Now let's put all of this together. So first thing we need to do is we create a new prototype. That's derived from the HTML element prototype. And then we use the created callback to add some functionality in there, because that way I have access to each element and can set the properties accordingly and do all the magic that's required here. So at that point, I need to get a handle of this template node again. That's pretty much what we saw before. I clone this template so that I have this subtree that I want to use for my web component. I need to get the host node in this case, because I'm in the callback. It's just this, and then I need to set set the value in my copy of the template, because from a template I just get the empty static code. I haven't set any data yet. Nothing dynamic is happening, so I need to do that now manually. I get the attribute icon source, and I copy that into the source of the icon image that I used in my template. And the same for the time. I take the time attribute from my web component and copy that into my shadow DOM at the correct place to show it there. And then I need to create the shadow root. I attach the clone to that. And last but not least, I need to register this new component so that the browser knows about it and can actually call that callback when it needs to create such an element. Native browser support is even worse than what we saw before. It's really just implemented in very recent versions of Chrome and Opera, and the other browsers don't support it yet. But again, using the polyfill library, we can use this kind of functionality already today. So, last piece of the puzzle, the HTML imports. When we look at the code, the way it is right now, so this is the website. I guess you can't really read it. So I added these parts. What we can see now is the blue parts, that's the application code, while the green part, that's the component. And there's obviously a mismatch, right? We just want to focus on our application code, and we don't want to have it that large just by having all the components within the application code. What we actually want to do is we want to take this part of the component out and focus just on our application code, which would also allow us to reuse it more easily, and actually so that you can use third-party components in your application. We need to have some mechanism so that we can import this kind of the component code into our application. And HTML imports give us exactly that. How does it work? So we have these two parts, the application code and the component code. The component code needs to be stored in another HTML file. Let's call it activity card. And then we use the HTML import to import this new HTML file. And what the browser does when it encounters this import, it loads the other website or the other HTML file and injects it into our code so that it is available. And with that, we have a nice separation of our application code and our component code.
What's your recommendation? Is the recommendation to have one HTML for each component, or can you have multiple components in one HTML? Or what's the recommendation?
My recommendation would be to have during development have the components in individual files so that you can easily assemble them and use the files you have. But then for the application, it actually makes sense to put everything into one large file so that the download so that you have just one download. So for the running environment, it makes sense to have one large file instead of multiple small files. Yeah, browser support is very similar actually to the custom elements. It's supported in Chrome and Opera, but just in very recent versions. The other browsers don't support it. But again, this polyfill library helps us there. And that's the web component standards. So we have looked at the element template, which allows us to extract boilerplate code and reuse it in our application. Then we looked at the shadow DOM, which helps us to encapsulate our web component so we don't accidentally mess with it. We looked at the custom elements, which help us to actually give meaning to our web component and use tags that we can actually read instead of just using div for everything. And then we looked at HTML imports, which allows us to separate web components from our application code. Oh, please.
Okay. So after we have seen this official specification, maybe you have seen there's a problem. Today, most of the browsers don't support this. This specification is very new. I think it's not finished, right? It's not finished today. And because of that, most of the browsers that we use today don't support it. But if you want to use it today, there's a solution, because there's a polyfill that is called webcomponents.js. So this is a JavaScript polyfill that can be used to use web components today. If you want to try it or to use it, you can just install it with Bower as a dependency to your application. And then you, like any other JavaScript, you just import or add the script to your website. And by doing so, you can do most of the stuff that you can do with a web component specification. The polyfill is created open source, and it's a junction of two other frameworks. The one is X-Tag that is developed by Mozilla, and the other one is Polymer that is developed by Google. And yeah, they joined forces and created a base API or polyfill that is called Web Components JS, and both of these implementations, Polymer and X-Tags, base on Web Components JS today. But to create your own web components or something like this, you don't need this X-Tag or Polymer. They will add some additional function that we will see later. Yeah, I already said this. So if you want to use it, there's a tutorial and a lot of articles on the webcomponents.org website. This website is, when starting working with web components, I think it's the best site to start. Okay, as said, we have X-Tag and Polymer, so maybe have a short look at both of them. Polymer is created by Google, so it's Google's implementation of web components. They started with this, and today we have these two layers. We have web components on the base, and then Polymer based on it. But this was changed at the end of last year. So before, Polymer don't depend on web components JS because there wasn't any web components JS. In Polymer there was its own base library called Platform JS since the end of the last year. And yeah, what Polymer does, it adds some additional APIs on top of the web components JS, like some additional functions or features, and they have some UI elements and tools too that we will see later. One of the core new functions that Polymer JS adds to Web Components JS is data binding. By using Polymer, you can use data binding in your web components, which is not part of the standard. On the other hand, X-Tag is created by Mozilla, and yeah, today this depends on Web Components JS 2, and yeah, it's not 1 month ago that they started to depend on this. So this is very new technology that we are talking here about. Yeah, and X-Tag 2 adds some API sugar on top of the Web Components JS. And as you can see here, for example, for X-Tag, yeah, it's supported by a lot of more browsers than we have seen for the original specification. So by using Web Components JS and maybe X-Tag on top on it, or only Web Components JS, it will be supported by a lot of more browsers and browser versions than just using the specification without any polyfill. Like Polymer, X-Tag is based on the Web Components JS and adds some additional features. Okay, so what do we have? We have a specification, and we have the first implementations of the specification and polyfills. So we think the next steps when we have web components, what we want to do, we want to create web components that can be reused. Not only by a project, maybe open source web components that I can add to my project or something like that. Or if we go bigger, we want to have toolkits. For example, in other UI languages, we have complete toolkits with special components, custom components, or its own skins. And with web components, we could have the same too. And some big companies are currently working on this stuff. For example, Google is working on web components, and what they are doing, they build custom web components based on the Google APIs. For example, Google has this Google Shard API. And today, Google is providing a web component called Google Shard. And by adding this web component, you can add directly a shard into your web application. Or there's a Google Hangout web component that you can add to your application. And then the Google Hangout button, it's a German one, it's Hangout Starts, will be shown in the right skin in the right layout in your application. So this is an example for reusable web components that are open source that you can just use in your application today. And the other thing are toolkits or themes. So without web components, today we have different one for the web. I think the biggest one that most of people will know is Twitter Bootstrap. So what is Twitter Bootstrap? It's something like an UI toolkit or skin for web applications that is mostly based on CSS. So for using Twitter Bootstrap, you need to include a CSS file and JavaScript file that add some additional functionality to Bootstrap to your application, and then you can use the tags and classes that are defined by Twitter Bootstrap in your application to, for example, define responsive layouts or to style your buttons or your sliders this way. And this has nothing to do with web components, right? It's just CSS, so you just style components that are there today, like button, div, or something like that. And what you can do with web components, if you want an UI toolkit, is shown by Google. And what Google does, it's created based on its Polymer library, something like an UI toolkit called Polymer Paper. And it's a toolkit that contains a lot of custom web components that add some web components that are only for layout. So something like layout containers you maybe know from Swing or JavaFX or something like that. And in addition, some icon sets and all this stuff so that everything looks right and looks in the same skin. So when looking at Bootstrap and Polymer Paper, what is the difference? So one difference is Bootstrap is fine. Yeah, there's a version 3 currently out, so it's everything good. You can use it. Polymer is currently in development, and there's a developer preview, so if you want to use it, I don't know if I want to use it in a productive application today. But on the other side, Polymer is based on modern web technology. There are web components that are reusable. I will show some examples later. And Bootstrap is based on CSS. So it's an old solution. Okay, so we have this Polymer paper. So the question is why Google does this. Why Google create Polymer, and why does Google create Polymer paper based on this Polymer? So maybe some of you may know that last year Google has introduced material design, which is or should be Google's default skin or default UI for all the applications. It should be responsive. So here's an example how it looks. It should work on desktops, on tablets, on mobiles, and it should work native on the one side and in the web on the other hand. And when looking at web applications, at Google's web applications today, like for example YouTube or Google+, you see, okay, it looks like Google, but when having a look at the toolbar, it's different, right? The toolbar don't look the same. And I think when Google has a good web component stuff, they can rebuild the stuff based on web components that can be shared between different applications like Google or Google+ or YouTube, for example. So what are the important features of this toolkit? It needs responsive design because it should work on mobile and on desktop. It must be customizable. So you must change colors or something like that because when you want to use it in your own applications, or just look at Google Mail. Google Mail is red by default, for example, and all the other stuff is, Google+, I think there are a lot of green elements, for example. So you must style it or change the colors, and it must be easy to use and extendable. And so how does it look? when using this library, so for example, it looks like this. So this is one, I can show the live. Demos, it's here we go. So, oh, okay, just a second. Nee, nee. Ah, there it is. Okay. So let me see. Oh, shit. How can I do it? Maybe this way. Ah, perfect. Okay. So because the screen is too small, it looks like the mobile version, not the desktop version here on this screen. But this is an example where you see some titles in different colors. You have this menus. And when showing this on a desktop, for example, the menu is on the left by default. So it's responsive. You don't need to slide it in or slide it out. It's there by default. And yeah, there are a lot of different components. And what is very nice, they have added animations, for example, by default. So when using this UI toolkit, you will have animations by default. So there are some other examples like this one or this one, this one. Okay, so Polymer Paper contains layout containers, components, animations, and icons. And so if you want to use it, every component is defined as a module that can be installed by Bauer, and then you can, by using the import function that is part of the web component spec and that you can use when using web components.js, you can simply import any component into your website and use it. For example, here is an example how to use buttons in your website. By doing so, the buttons will look like shown on the bottom. Or maybe the checkboxes, the Polymer Paper checkboxes, maybe a dialog, for example. It's just this code to add this dialog to your application. So there are a lot of more components like tabs or labels, I don't know, buttons, radio buttons, pop-up menus. There's a big icon library part of it so that you can use these icons in your application. And as said, there are some layout containers as web components. So one example is a toolbar. By using the toolbar, automatically a toolbar will be shown on top of your application, and everything that you add to the toolbar, so like the div or a span, will be layouted in the toolbar. To do so, Polymer defines some layout attributes. They're defined by Polymer, and you know how to use it, and when you use them, you can do a lot of layouting stuff in Polymer. In addition, and I think this is one of the core layout containers in Polymer, is a header panel. So the header panel defines a toolbar and a content in the bottom of the toolbar and the rest of the screen. And for example, if the content is bigger than the screen, only the content, you can only scroll the content. The toolbar will always be on top. Another layout, for example, is a drawer panel. We have seen this. It puts a menu, it places a menu on the left side, and then you can, it's responsive by default. It looks like this, and when it's smaller or on a mobile, you need to click a menu button to show the menu. And even this is not much code, right? This is the code for the layout, for the menu button, for the toolbar, and for some content. And if you even want less code, they have this scaffold. It's like a basic skeleton for an application. So it's just, let me see, 1, 2, 3, 4, 5, 6 lines of code, and it does what we have seen. It adds the toolbar, it adds the default menu, it adds the content area that we just need to fill. But the complete layout is defined by the scaffold. So maybe a sample how we can use it. So to use it, just create an idea, call Bauer init, and then install Polymer Paper elements, which automatically downloads all Polymer paper modules. Then create an index HTML. So this is normal HTML, no web components at all. Add the web components JS library to have this better web component support in more browser versions. Then change the font to the default Polymer font. This is just one line of CSS. And yeah, now our application will look like this. So what can we do now? We can import Polymer components like the core toolbar or the core header, and then use the tags in our HTML page. And now our application will look like this. So maybe as the next, we change the toolbar color to orange. So it will change. Very easy. So maybe now skin the toolbar or add components to the toolbar. For example, we have this paper icon button in Polymer paper. Now application will look like this. And maybe as the last step, add some content to the content area, an input field, and a button. And our application will look like this. So at last, maybe do some padding. And yeah, this is the final application. And it's very easy. It's only a few lines of code. Maybe at the end, I can just show it. Is it here, right? Can I? We don't have time. Okay, so we don't have time to show this example live. But it's very easy. It's like it was shown on the slide. In addition, there's a designer for Polymer online. So it's what you see is what you get designer. It's okay. It's okay to try Polymer and to play a little bit with it. I won't use it in production. I have tried it, not for production, but I have tried it, and it's okay to play with it, but it's not perfect. So it looks like this. Yeah? So you have here your working area, and then you can define attributes and all the stuff for the components that you use. And by doing so, you can create cool applications. This is an example. It's someone created a Google Mail application just by using Polymer. It's not much code, and it looks like this. It uses the default Polymer components and default Polymer icons. Yeah, and I think it's very cool. So if you want to use web components, I think the most important website to start is webcomponents.org. Everything is described there. There are links to the implementations like Polymer or X-Tag. And if you just want to reuse web components or use web components in your application and don't want to create your own web components, there are two sites. It's component.kitchen and customelements.io. These are catalogs or repositories for web components. And you can download them and use them in your code. So I think we're out of time, right? 2 minutes for questions.
And we have T-shirts for that.
And we have T-shirts.
So I think there were already questions here.
Okay. There was a question. Yeah, you? And Android, what was it? Yes? So web components are default, right? So AngularJS is just a framework, and it can change any time. And web components are a specification, an HTML specification, and it will be a default that is implemented by any browser by default in some future. And for example, Angular version 2 that will come maybe next year will be based on this default. So Angular 2 will be based on web components.
Can I add something?
Yeah, sure.
So I think the question is, in more general, what does a standard provide, right? AngularJS gives us this already. You know, you can define templates, and you have directives which are kind of like custom elements. But it's not a standard. If you want to use Angular, you just use Angular, and you can't use anything else, right? If you have a standard, you can suddenly think about things. You know, somebody writes a web component using GWT, for example, and you can use it in your Angular application because now it's based on a standard. It's not a specific implementation. So I don't think that web components really give you anything new on functionality, but it gives you the platform as standard so that you can reuse web components done with different implementations, which is certainly a huge value add.
Yes?
Can you just quickly expand on why you wouldn't use Polymer?
I don't say that I would not use Polymer. What I said is in production. Yeah, I don't know. So it's Google called it developer preview. And when we prepared this talk, even in the time where we created the slides, things in Polymer changed. They added some new text that makes stuff easier, and we needed to change the code in our slides because it was just half of the code then and all the stuff. So maybe if you have a project that will, I don't know, go live in 1 year or something like that, then you can use it definitely. And all the examples that we have created are working very good on all the browsers. It's very good, but so it's so new that we don't know how good it is. We just started at the end of the year to use it and to play with it, and I can't decide it at the moment. That's the only point. Yes? Or we start here. Yes?
You mentioned earlier that you wouldn't use Bootstrap any longer. You would preferably use Polymer, right?
Yeah, it depends. So Polymer.
What's the reason behind that? I saw you have a slide where there's Bootstrap.
Yeah, what I want to do is I want to have a web component based UI toolkit in future, and I think it's better than Bootstrap because when using Bootstrap it's okay, but you will have problems. You can't simply change the layout or add other different layouts and stuff like this. And when using web components, it's no problem to put pieces together like this web component and this one and maybe this UI toolkit as a base. So I don't want to say that I won't use Bootstrap today because I said I don't know if I want to use Polymer today. So we're at a point today maybe use Bootstrap and in a year maybe use Polymer. I don't know. So yes? One last question. Okay. So there was a question. It was. No.
I was just thinking if I want to mix with other web components, like jQuery UI or maybe Google Maps, or if it's possible to put this template in like half of the page or.
So your question was if there are other web components by Google like Google Maps or. The mic is coming, so I don't understand. Sorry.
If I want to mix the Polymer with, for instance, jQuery UI, I want to use a calendar, and maybe I want to use a Google Map, and I have some other frameworks, jQuery frameworks I'm using, and can I just put the template in half of the page or somewhere, and or are I really bound to the whole structure and for the whole web page?
So what you can do is you can, for example, create import files for maybe toolkits or something like that. So if you says, okay, everything that is part of Google, like a Google Map that I want to add or any Google button, I can create my own import file for all this Google stuff, then import the Google stuff there, and then import this file in my application, for example. And by doing so, you can structure it. And by using web components, it's no problem to mix it. For example, to mix Google Web Components with, I don't know, maybe there are, I have no other idea, like Google, any other web components. You can mix it easily. So maybe in a year we have a new version of Bootstrap where the Bootstrap layout is defined by web components. They don't use this CSS style anymore. They have Bootstrap web components that internally uses this style and defines it. Answers this the question?
Yeah, sure.
Okay, perfect. Thank you. Okay, thank you.